Lesson 1. Classifying Matter. Reading Guide. Key Concepts. Essential Questions. What is a substance? How do atoms of different elements differ? How do mixtures differ from substances? How can you classify matter? Vocabulary. Matter. Atom. Substance. Element. Compound. Mixture. Heterogeneous mixture. Homogeneous mixture. Dissolve. Inquiry. Making green? You probably have mixed paints together. Maybe you wanted green paint and had only yellow paint and blue paint. Perhaps you watched an artist mixing several tints get the color he or she needed. In all these instances, the final color came from mixing colors together and not from changing the color of a paint. Understanding matter. Have you ever seen a rock like the one in Figure 1? Why are different parts of the rock different in color? Why might some parts of the rock feel harder than other parts? The parts of the rock look and feel different because they are made of different types of matter. Matter is anything that has mass and takes up space. If you look around, you will see many types of matter. If you are in a classroom, you might see things made of metal, wood, or plastic. If you go to a park, you might see trees, soil, or water in a pond. If you look up at the sky, you might see clouds and the sun. All of these things are made of matter. Everything you can see is matter. However, some things you cannot see also are matter. Air, for example, is matter because it has mass and takes up space. Sound and light are not matter. Forces and energy also are not matter. To decide whether something is matter, ask yourself if it has mass and takes up space. An atom is a small particle that is a building block of matter. In this lesson, you will explore the parts of an atom and read how atoms can differ. You will also read how different arrangements of atoms make up the many types of matter. Atoms. To understand why there are so many types of matter, it helps if you first learn about the parts of an atom. Look at the diagram of an atom in Figure 2. At the center of an atom is a nucleus. Protons, which have a positive charge, and neutrons, which have a neutral charge, make up the nucleus. Negatively charged particles, or electrons, move quickly throughout an area around the nucleus, called the electron cloud. Reading check. What are the parts of an atom? Not all atoms have the same number of protons, neutrons, and electrons. Atoms that have different numbers of protons differ in their properties. You will read more about the differences in atoms on the next page. An atom is almost too small to imagine. Think about how thin a human hair is. The diameter of a human hair is about 1,000,000 times greater than the diameter of an atom. In addition, an atom is about 10,000 times wider than its nucleus. Even though atoms are so tiny, they determine the properties of the matter they compose. Substances. You can see that atoms make up most of the matter on Earth. Atoms can combine and arrange in millions of different ways. In fact, these different combinations and arrangements of atoms are what makes up the various types of matter. There are two main classifications of matter: substances and mixtures. A substance is matter with a composition that is always the same. This means that a given substance is always made up of the same combination or combinations of atoms. Aluminum, oxygen, water, and sugar are examples of substances. Any sample of aluminum is always made up of the same type of atoms, just as samples of oxygen, sugar, and water each are always made of the same combinations of atoms. To gain a better understanding of what makes up substances, let's take a look at the two types of substances. Elements and compounds. Key elements. Look at the periodic table of elements on the inside back cover of this book. The substances oxygen and aluminum are on the table. They are both elements. An element is a substance that consists of just one type of atom. Because there are about 115 known elements, there are about 115 different types of atoms. Each type of atom contains a different number of protons in its nucleus. For example, each aluminum atom has 13 protons in its nucleus. The number of protons in an atom is the atomic number of the element. Therefore, the atomic number of aluminum is 13, as shown in Figure 3. The atoms of most elements exist as individual atoms. For example, a roll of pure aluminum foil consists of trillions of individual aluminum atoms. However, the atoms of some elements usually exist in groups. For example, the oxygen atoms in air exist in pairs. Whether the atoms of an element exist individually or in groups, each element contains only one type of atom. Therefore, its composition is always the same. Key concept check. Compounds. Water is a substance, but it is not an element. It is a compound. A compound is a type of substance containing atoms of two or more different elements chemically bonded together. As shown in Figure 4, carbon dioxide, CO2, is also a compound. It consists of atoms of two different elements, carbon, C, and oxygen, O, bonded together. Carbon dioxide is a substance because the C and the O atoms are always combined in the same way. Chemical formulas. The combination of symbols and numbers that represents a compound is called a chemical formula. Chemical formulas show the different atoms that make up a compound using their element symbols. Chemical formulas also help explain how the atoms combine. As illustrated in Figure 5, CO2 is the chemical formula for carbon dioxide. The formula shows that carbon dioxide is made of C and O atoms. The small 2 is called a subscript. It means that two oxygen atoms and one carbon atom form carbon dioxide. If no subscript is written after a symbol, one atom of that element is present in the chemical formula. Properties of compounds. Think again about the elements carbon and oxygen. Carbon is a black solid and oxygen is a gas that enables fuels to burn. However, when they chemically combine, they form the compound carbon dioxide, which is a gas used to extinguish fires. A compound often has different properties from the individual elements that compose it. Compounds, like elements, are substances, and all substances have their own unique properties. Mixtures. Another classification of matter is mixtures. A mixture is matter that can vary in composition. Mixtures are combinations of two or more substances that are physically blended together. The amounts of the substances can vary in different parts of a mixture and from mixture to mixture. Think about sand mixed with water at the beach. The sand and the water do not bond together. Instead, they form a mixture. The substances in a mixture do not combine chemically. Therefore, they can be separated by physical methods, such as filtering. Heterogeneous mixtures. Mixtures can differ depending on how well the substances that make them up are mixed. Sand and water at the beach form a mixture, but the sand is not evenly mixed throughout the water. Therefore, sand and water form a heterogeneous mixture. A heterogeneous mixture is a type of mixture in which the individual substances are not evenly mixed. Because the substances in a heterogeneous mixture are not evenly mixed, two samples of the same mixture can have different amounts of the substances, as shown in Figure 6. For example, if you fill 2 buckets with sand and water at the beach, one bucket might have more sand in it than the other. Homogeneous mixtures. Unlike a mixture of water and sand, the substances in mixtures such as apple juice, air, or salt water are evenly mixed. A homogeneous mixture is a type of mixture in which the individual substances are evenly mixed. In a homogeneous mixture, the particles of individual substances are so small and well mixed that they are not visible, even with most high-powered microscopes. A homogeneous mixture also is known as a solution. In a solution, the substance present in the largest amount is called the solvent. All other substances in a solution are called solutes. The solutes dissolve in the solvent. To dissolve means to form a solution by mixing evenly. Because the substances in a solution or homogeneous mixture are evenly mixed, 2 samples from a solution will have the same amounts of each substance. For example, imagine pouring 2 glasses of apple juice from the same container. Each glass will contain the same substances, water, sugar, and other substances, in the same amounts. However, because apple juice is a mixture, the amounts of the substances from one container of apple juice to another might vary. Key concept check. How do mixtures differ from substances? Compounds versus solutions. If you have a glass of pure water and a glass of salt water, can you tell which is which just by looking at them? You cannot. Both the compound, water, and the solution, salt water, appear identical. How do compounds and solutions differ? Because water is a compound, its composition does not vary. Pure water is always made up of the same atoms in the same combinations. Therefore, a chemical formula can be used to describe the atoms that make up water, H2O. Salt water is a homogeneous mixture or solution. The solute, NaCl, and the solvent, H2O, are evenly mixed, but are not bonded together. Adding more salt or more water only changes the relative amounts of the substances. In other words, the composition varies. Because composition can vary in a mixture, a chemical formula cannot be used to describe mixtures. Summarizing matter. You have read in this lesson about classifying matter by the arrangement of its atoms. Figure 7 is a summary of this classification system. Key concept check. How can you classify matter?